Q learning in reinforcement learning. AI advanced level. Introduction. In reinforcement learning, agents learn by interacting with an environment and receiving rewards. One of the most important algorithms in RL is Q learning. Q learning allows an agent to learn which actions to take, in which states, to maximize long-term rewards. It is a model-free, value-based algorithm and is widely used as a foundation for more advanced methods like deep Q networks. DQN. What is Q learning? Q learning is a reinforcement learning algorithm that learns the value of taking a particular action in a given state. In simple terms, Q learning equals learning the best action using a value table. Q table. Example concept. State plus action means Q value means best decision. What is Q value? The Q value represents the expected future reward for taking an action in a given state. Example concept. Q S A equals expected reward for action A in state S. The agent chooses the action with the highest Q value. Why Q learning is important? Q learning is important because it does not require a model of the environment, learns optimal policies through experience, is simple yet powerful, works for many decision-making problems, forms the basis for deep reinforcement learning. Example concept. Learn values means choose best actions means maximize reward. Q learning workflow. The Q learning process. Initialize Q table. Down pointing arrow. Observe state. Down pointing arrow. Choose action. Down pointing arrow. Take action. Down pointing arrow. Receive reward. Down pointing arrow. Update Q value. Down pointing arrow. Repeat until convergence. Q learning formula. The core update rule. Q S A. Left pointing arrow. Q S A plus alpha R plus gamma max A single quote Q S single quote A single quote minus Q S A Q S A left pointing arrow Q S A plus alpha R plus gamma A single quote max Q S single quote A single quote minus Q S A where Q S A means current value, alpha means learning rate, R means reward, gamma means discount factor, max Q S A means best future reward. Explanation of the formula. Example concept. New Q value equals old value plus learning adjustment. Steps. Take current Q value. Add reward plus best future reward. Adjust using learning rate. Q table. Q learning stores values in a table. Example. Action 1 Action 2. State 1 5 2. State 2 8 1. The agent chooses the action with the highest value in each state. Exploration versus exploitation. Exploration. Try new actions to discover rewards. Exploitation. Use known best actions. Example concept. Explore means learn. Exploit means maximize reward. Common method. Epsilon greedy strategy. Epsilon greedy strategy. Example concept. With probability epsilon means explore. With probability 1 epsilon means exploit. This balances learning and performance. Example intuition. Imagine a robot in a maze. Tries different paths. Exploration. Learns which path gives reward. Eventually finds the shortest path. Example Python code. Import numpy as np. Q equals np. Zeros. 3. 2. Number 3 states. 2 actions. Alpha equals 0.1. Gamma equals 0.9. State equals 0. Action equals 1. Reward equals 10. Next underscore state equals 1. Q. State. Action plus equals alpha. Reward plus gamma asterisk np dot max. Q. Next underscore state. Q. State. Action. Print. Q. Advantages of Q learning. Advantages include simple and easy to understand. Does not require environment model. Guarantees optimal policy. In theory. Works well for small environments. Example concept. Value learning means optimal decisions. Limitations of Q learning. Limitations include does not scale well for large state spaces. Requires large memory for Q table. Slow convergence in complex problems. Struggles with continuous environments. Deep Q learning. DQN. To handle large problems. Q learning is combined with neural networks. Example concept. State means neural network means Q values. This is called deep Q network. DQN. Applications of Q learning. Game AI. Learning optimal strategies. Robotics. Navigation tasks. Autonomous systems. Decision making. Resource optimization. Scheduling. Routing. Q learning versus other RL methods. Q learning. Value-based. Model-free. Policy gradient. Directly learns policy. Actor critic. Combines value and policy. Future of Q learning. Future trends include deep reinforcement learning, improved exploration strategies, multi-agent learning, real-world applications. Example concept. Q learning means foundation of modern RL. Concepts learned from Q learning. Understanding Q learning helps learners understand. Checkmark how value-based RL works. Checkmark how agents learn optimal actions. Checkmark how rewards guide learning. Checkmark how policies are derived from values. Checkmark how RL scales to deep learning. Simple definition. Q learning. A reinforcement learning algorithm that learns the value of actions in states to maximize long-term rewards. Final summary. Q learning is a fundamental reinforcement learning algorithm that helps agents learn optimal actions using a Q value table. It is model-free, value-based, and widely used in decision-making problems. Although it has limitations in large environments, it forms the foundation for advanced methods like deep Q networks. Understanding Q learning is essential for building intelligent decision-making AI systems.